Hello friends, in today's lecture video we are going to learn about other transformation. We already discussed in 3D transformation, that is translation, scaling and rotation. Now what are the other transformation? It's all about reflection and shears, right? Now what is reflection? Reflection means it is a mirror image produced when mirror is placed at required position. Now when mirror is placed in xy plane, we obtain coordinates of image by just changing the sign of z coordinate. And what is shearing transformation? That is, it is the modify the object shapes, right? So whenever we require to modify any kind of object in shape, then we can use shearing transformation, right? And they are also useful in 3D viewing for obtaining general projection transformation. So let's see reflection and shear transformation. First, reflection transformation. We are going to discuss about reflection transformation. So a 3D, that is three-dimensional reflection matrix, are set up similarly to those for two dimension, and reflection relative to a given axis, that is equivalent to 180-degree rotation about the axis, and reflection with respect to a plane are equivalent to 180 rotation in four-dimensional shape, right? So the reflection is relative to xy, yz and zx plane. Let's see with the example. Now first is reflection about its relative to xy plane, right? First reflection. So how it works? So let make three axes, that is x axis, y axis and z axis. So suppose I have to reflect this to xy plane, right? This z will be reflect to xy plane. So how it will be reflect means, this is our x and y coordinate, and this z is supposed to be reflect like this, right? So this z will be here. So we can say that this reflection relative to the xy plane, right? So how we make this reflection matrix? So reflection matrix RF means reflection matrix with z axis in xy plane. So what will be the matrix? That is 1 0 0 0 0 1 0 0 0 0 minus 1 0 and 0 0 0 1. Why it should minus 1 over here? So you already know that it's a x axis, y axis, z and extra coordinate, right? X, y, z and extra coordinate. So we are to reflect z. So value of z, it will be minus 1 because we are reflecting this z in xy plane, that's why, right? So similarly we have to find another plane. So second is reflection relative to which YZ plane, right? So second one is reflection relative to XZ plane. So suppose we have this 3D 3 axis x, y and z. Now I want to do reflection relative to XZ plane, right? Reflection relative to the XZ plane. So this plane x and z. So y is reflected over here. So after reflection, how we can see that this is x and z plane, and this y should be reflected here. This is our y axis, right? So this way we can reflection relative to the XZ plane. Now what will be the transformation matrix, that is R F Y, reflection about y, that is 1 0 0 0 0 minus 1 0 0 0 0 1 0 0 0 0 and 1, because this is a reflection about y. So here we take minus 1, right, for y. This is the reflection matrix relative to XZ plane. Similarly, we have to do matrix for reflection about YZ axis. Reflection relative to YZ plane, right? This is our 3 plane x, y and z. Now reflection about YZ. So this is y and z axis. So reflection of this x, it is in YZ plane, like this, right? So we can say that this is the figure of reflection relative to the YZ plane, right? And matrix of YZ plane, that is reflection of x, is equal to minus 1 0 0 0 0 1 0 0 0 0 1 0 and 0 0 0 1, right? So this way we can do reflection in 3-dimensional transformation, right? Now let's see Shear's transformation. Next topic is Shear transformation. Shear transformation can be used to modify object space, right? It can be modify object shape. They are also used in 3D viewing, right? They are also used in 3D viewing for obtaining general projection transformation. Here we use shear parameter like a, small a, and b. Here we used shear parameters like a and b. Shear matrix for z axis is shear matrix for z axis is given. Here we are using capital S, H and H for shear transformation with respect to z axis. So this matrix will be written like 1 0 a 0 0 1 b 0 0 0 1 0 0 0 0 1, right? Because shear means suppose I want to shear this object, right? So it will be shear like this, means we can modify this object like this, right? So it is shear transformation. So a and b value will be shear. That's why we are using a and b parameters. Similarly, we get shear matrix for x axis is, now it is shear about x axis. So matrix will be 1 a b 0 0 1 0 0 0 0 1 0 and 0 0 0 1, right? Similarly, we get equation for y axis. Shear matrix for y axis, that is SHY is equal to 1 0 0 0 a 1 b 0 0 0 1 0 and 0 0 0 1. This is a shear transformation related to y axis. The transformation matrix to produce shear relative to x, y and z axis are shown in this matrix. Now shear transformation are used to modify the shape of the object, and they are useful in three-dimensional for viewing, for obtaining general projection transformation. So whenever we have to do projection, we can use that shear transformation. Now I hope that you cleared with reflection and shear. This way we can solve the example of shear and reflection transformation. I hope this matrix will be useful in to solve example. Thank you for watching.